Hello students, we'll start topic 2, right? Lesson number 6, functions. Okay, this section we are going to do faster because I want to complete it before the end of this month, right? You have exam on 30th of October and the next day 31st. 30th October you have paper 1 and 31st you have paper 2 and 3 together, right? Okay, so in functions we are going to study different parts of the equation, different forms of the equation of a straight line, gradient intercept form, lines with gradient m1 and m2, parallel and perpendicular lines, then concept of domain, range, graph of function, inverse of a function, right? All these things we are going to study. The graph of function with equation y is equal to f of x, and creating a sketch of the information given, and then determine key features of the graph, right? Okay, so this is from your book. In this chapter there is line and Cartesian plane, graphing a straight line, perpendicular bisectors, simultaneous equations, right? Okay, equation of a line, y is minus y1 is equal to m into x minus x1. So if you have 2 points on a line, right? If you have 2 points on a line, point A is x1 y1, point B is x2 y2, okay, then either you should have 1 point or you can have 2 points. So suppose you have only 1 point, right? And you have the gradient. I'll show you this one later on, and you have the gradient. Then equation of this line is y minus y1, the y coordinate of the given point, is equal to m, the gradient of the line, into x minus x1, the x coordinate of the given point. Like this you get the equation of a line. Then y is equal to mx plus c. For this equation, okay, if you have, right, if you have something like this, let me show you. You have a line whose y-intercept is given c here, 0 comma c, and whose gradient is given m, then its equation is y is equal to mx plus c. You all know about it. Now this form and this form both together can be simplified, and we can write the general form in this way, okay? So suppose if you have an equation, if you have gradient m is equal to 1 by 2 and the point is 0 and 3, then slope intercept form or gradient intercept form will be y is equal to m is 1 by 2, okay, m into x plus c will be this 3, y-intercept. So this is the gradient intercept form. Now multiply by 2, so you will get 2y is equal to x plus multiply by 2 to this 3, 6. Then to write in this form, it means x and y should be on one side, constant should be on the other side, and try to keep the x positive. So we'll bring y here and take x there. So this will become x minus 2y is equal to minus 6. This is the general form, right? So like this you can convert any equation in the general form. Okay. Now this question says find in gradient intercept form, means y is equal to mx plus c, the equation of the line which has the gradient 3 and passes through 4 and 1, right? So to find the equation of this line, we have, this is x1 y1, this is m. So y minus y1 is equal to m into x minus x1, right? So y minus 1 is equal to m is 3, x minus 4. So y is equal to 3x minus 3 times 4, 12, and 1 will go there, become plus 1. So y is equal to 3x minus 11. This will be the answer for the gradient intercept form, right? They wanted like that, right? I hope you understood. There is nothing difficult. Okay. Next question says the graph alongside this graph, in this graph shows the descent of a train down a hill the units are in meters. Okay, everything is given in meters. Calculate the gradient of the train's descent. It means m we have to find. Descent or ascent means gradient we have to find, right? So what we are going to do for that? We will find gradient from the given 2 points. Look here, this point is, so there are A 1820 comma 0, this is point A, and this is point B 0 comma 46, 2 points. Therefore m is equal to, what is the formula for the gradient? y2 minus y1 over x2 minus x1, right? So this is x1 y1, this is x2 y2. So y2 minus y1, 46 minus 0 over x2 minus x1 minus 820, 1820. So 46 divided by negative of 1820. Okay, when I simplify this, 46 divided by 1820. So in simplified form it will be negative of 23 by 910. This is the gradient of, or this is the descent of the train, is descent of the train, right? So which will be treated like the gradient, right? This will be m. Now the next part says find the equation of the train line. Okay, so we have one point on it. This one we can take, or this one we can take, whatever point you want to take. Better I will take this one, small values are there. So therefore in the B part, equation of line is y minus y1. I am using point A, using A1 8, I am using point B as I told you just now, 0 comma 46, because small values. So y minus 46 is equal to m. M is minus 23 by 910. X minus x1 0. So x1 and y1 are this. So therefore y is equal to minus 23 by 910x, and this will go there, become plus 46, right? So this is the equation of train line. Okay. Yeah, there was nothing difficult. You all know about it. So we'll go fast, right? Okay. Next question says find the equation of the line which is parallel to this and passes through this. See, parallel and perpendicular line, let us see. Suppose if you have two parallel lines with gradients m1 and m2, then m1 is equal to m2. And if you have two perpendicular lines like this, something like this, this has gradient m1, this has gradient m2, then we write m1 multiplied by m2 is equal to negative 1. Okay, this is the property of parallel and perpendicular lines. Let me make it more perpendicular. Yeah, these are perpendicular to each other. Okay, so here parallel to this. So here m will be same as the given equation. So m is equal to 3 and point is 1 comma 4. Therefore equation of parallel line y minus 4 is equal to 3 into x minus 1. So y is equal to 3x minus 3 plus 4. So this will give you y is equal to 3x plus 1. Okay, this is the equation of the required line, right? Then draw the graph of this equation. We have to draw the graph of this. Let me draw x and y coordinates. I mean the axis. X-axis, origin, y-axis. See here m is 1 by 2. It is positive. Okay. And y-intercept is c 1. So from here it will pass 0, 1 and gradient is positive. So its angle with the x-axis will be acute, right? Acute angle with the x-axis. So this is the equation of the line. This angle theta should be acute. See, if m is positive, theta acute. If m negative, theta obtuse. Okay, remember this property. Means more than 90 degrees. So if it is obtuse, the equation of line will be something like this. If the gradient was minus half and passing through and the y-intercept is 1, so same equation will be like this, but we don't have like that anyway. Okay. Next question. Solve by elimination. Elimination means cancelling the one of the variables. Okay. So when we add them, right? First equation, second equation. 1 plus 2 gives, when we add, y and y will cancel because positive y and negative y will cancel with each other. These two will get added. 4 plus 3, 7x is equal to these two also will get added. 9 and 5, 14. So x is equal to 2. This is the x coordinate. Put it in any one of the equation. So we'll put in the first equation or second. Let us put in the second equation. Therefore 4 into 2 plus y is 9. So y is 9 minus 8, which will be 1. So therefore 2, 1 is point of intersection, or is the solution also, you can say. Actually it is the point of intersection. So x is 2, y is 1. Okay. I hope you understood. There was nothing difficult. Now look here, functions we will start. Straight line part is over. We'll see some past paper questions. Okay. Relation and function. Function notation. What is the notation of the function? Domain and range of a function, rational function, composite function, and inverse of a function. Right. So look here. What is a function? Let us see the definition. A function is a relation in which no two different ordered pairs have the same x coordinate or first component. Actually, I can write it in other words. A relation is a function. A relation. 1 minute. A relation from set A to set B is a function if every element of set A has unique relation in set B. The above definition also means the same thing. I'll show you example what is the meaning of it. See, suppose here you have elements 1, 2, 3, 4, and here suppose you have 1, 4, 9, something like this. Now 1 is associated to 1, 2 is associated to 4, 4 is also associated to 4, and 3 is associated to 9. This is a function. Right? According to the above definition, which is in the blue shaded part, these ordered pairs, I will write the ordered pairs 1, 1, 2, 4, 3 comma 9 and 4 comma 4. See, these are the ordered pairs. What they said about it in the first definition, a function is a relation in which no two different ordered pairs have the same x coordinate or first component. See, the first component here should not be repeated, 1, then 2, then 3, then 4. So it is not repeated, therefore it is a function, right? But if they are repeated, then it will not be a function. So let me show you that. A second example. 1, 2, 3, 1, 4, 6, 9. 1 is associated to 1 and 1 is associated to 4, 2 is associated to 6 and 3 is associated to 9. Now this is not a function. Why? See, I'll show you from both the definitions. The second definition which I wrote here, I will highlight this also. This is also a correct definition, okay. The second definition says, look here, a relation from set A. Suppose this is set A, this is set B, set A, set B. So a relation from set A to set B is a function if every element of set A has unique relation in set B. The relation should be unique. So here each element has only one association, okay. But here 1 has two associations, with 1 as well as with 4. So this is not unique, okay. And if there is some element 4 which has no relation in the second set, then the first part of the definition which says every element of set A. So in every 4 will be left as it is, therefore again it will not be a function, right? Okay. Now for the ordered pair, let me write the ordered pairs here. 1 comma 1, 1 comma 4, 2 comma 6 and 3 comma 9. Now look here, these according to the first definition, a function is a relation in which no two different ordered pairs have the same x coordinate. Now look here, two different ordered pairs have the same x coordinate in these two, right? First two. Therefore this is not a function, okay, not a function. I hope you understood this part, right? Okay. Algebraic test for function. What is the algebraic test for function? Suppose a relation is given as an equation if the substitution of any x value for any value of x results in at most one value of y, then this relation is a function. See, I will give you example of it. For example, y is equal to 2x plus 1. Now any value of x will give me one answer. So look here, x is equal to 1. What will be the answer of y? Y is 2 into 1 plus 1. So 3. X is equal to 2. Okay, or x is equal to minus 1, suppose I take. So y will be 2 into minus 1 plus 1. So minus 1. So both the relations are unique. But I will choose another set. So this is a function. This is algebraic test of a function. Now I will choose another example. Y square is equal to x. So x is equal to 1 I will choose. So therefore y square is equal to 1 and therefore y will be equal to plus minus 1. Okay. So this one value of y concept is not cleared here, one value of y, at most one value. Here we are getting two values. Therefore, it is not a function. Right? Not a function. This is a function. I hope you understood this. Then geometrical test or vertical line test. Look here. If I have, let me draw two graphs. X-axis, origin, y-axis. Suppose I have a graph like this. Okay. Let me redraw. Yeah, like this I have a graph. Now what is the vertical line test? If you draw a vertical line on the graph anywhere, okay, not in a particular region or particular part of the graph, anywhere you draw the vertical line, so it passes through at most one point, exactly from one point. See, there are no 2 points, but I will draw another graph here. So this is a function. This is called vertical line test. Let me draw another graph now here. Okay, x-axis, y-axis. I will draw something like this. Okay. Now in this graph, if I draw a vertical line here, here, okay, anywhere you draw, it is meeting in more than one point. See, each vertical line is meeting in more than one point. So therefore, this is not a function. This is called vertical line test. Okay. Now graphical note. If look here, if a graph contains a small open circle like this open circle, this point is not included. Okay. So this first point, let me label them 1, 2, 3. So first point I will explain to you. Suppose I have a graph . See, so this point is not included, this is not included. Suppose if it was 1 and it was 5, so 1 is less than x is less than 5. They are not included. Okay. Or I can write the open interval 1 to 5. Now second example, where it says the graph contains a small filled in circle, such as this one. Okay. So I will draw one graph, and on the graph I will have filled circles like this from 2 to 11. So here 2 is included, 11 is included. So 2 less than or equal to x less than or equal to 11, or I can have closed interval 2 comma 11 and close the bracket. Okay. Now third example says, if the graph contains an arrowhead at an end such as this one, then the graph continues indefinitely in the general direction, or the shape may repeat as it has done previously. Look here. In case of a straight line, we know that straight line is an infinite set. Okay. So if there are arrows, then it will be extended infinitely. Okay. Or indefinitely. It continues. It will continue here. It will continue here. That is the meaning of arrowhead. Okay. Okay then. Now next question is, which of the following sets are of the ordered pair are functions? Explain your answer. Look here. 1, 3, 2, 3, 3, 1, 4, 2. The x element, the x coordinate is not repeated. So therefore it is unique. In this relation, in these ordered pairs, no x coordinate is repeated, therefore relation is unique, hence it is a function. Let us see second example. In the second example, look here, I will show you 2 1, see 2 1, 3 1, minus 1 2 and 2 0. See, particularly this 2 and here this 2 are repeated. So the relation is not unique. 2 has a relation with 1, 2 has a relation with 0 also. So therefore it is not a function, as 2 has relation with 1 and 0. Hence no uniqueness. Therefore it is not a function. Yeah, we already wrote about that. Okay, like this. Now another example. We already checked the graphical test. Use the vertical line test to determine which of the following relations are a function. Okay, so I will draw a vertical line here anywhere. So what do you observe? That these vertical lines are meeting the graph exactly once. Therefore A is a function, as vertical line meets graph only once. Now second one. See, if I draw any vertical line, it is meeting in more than one point. Yeah. So here as well as here as well as here. Okay. So vertical line test fails. Therefore not a function. What about the third one? It passes the vertical line test. See here. Anywhere you draw, it will meet the graph only once, right? Here one time. Therefore it is a function, as it meets the graph once. Look at this. Here it is only once. Here okay. But here, see, it is meeting at this point as well as at this point. So more than one point it is meeting. So therefore not a function. Okay. Yeah, so it was very simple. So this is not a function, this is not a function, this is a function, this is a function, right? Okay. Now look here, function has different notations. So in this way also we can write a function. F is a function such that x is mapped onto 2x plus 3. Okay. Or converted into, they wrote, but I will use mapped onto. Okay. Then there are two other ways also to represent the same function, like this: f of x is equal to 2x plus 3, or y is equal to 2x plus 3. In any ways you can represent a function. So f of x is the value of y, for which the given value of x, so that y is equal to f of x. Okay. Okay. Domain and range. Domain and range. So look here, the definition. These are the sets of values of x will be the domain, and set of values of y will be the range, which lie on the graph or which satisfy the equation of the graph. Those are called domain and range. Domain is set of all x values, range is set of all y values, which satisfies the graph or which satisfies the equation of the function. Okay. So domain is a relation. Domain of a relation is the set of values which the variable on the horizontal axis can take. Horizontal axis means x-axis. Can take this variable is usually x. Okay. Range of a relation is set of values which the variable on the vertical line can take. On this vertical line, this value, this value, this value, this value, this value, this value, this value. So those values will be in the range, these values will be in the domain. Okay. So the x values are called domain, the set of y values is called range, right? Okay. Question it is, for each of the following graphs, find the domain and the range. Domain as well as range we have to find. Look here, here it doesn't meet, here it meets. Okay, the x value and the y value both. So domain will be, let me write with black, set of all x belongs to R such that 1 minus 1 less than x less than or equal to 5. Means minus 1 is not included but 5 will be included, okay? And range, set of all y values such that, now look here, y values, again it will not be satisfied, here it will be satisfied. So 1 less than y less than or equal to 3, okay? These are called domain and range. So I hope you understood for B part also, but there we have an asymptote. Look here, this is asymptote. So domain or range will not pass through the asymptote, right? Means we will not have values of domain or range on the asymptote. So therefore, considering that, domain will be set of all x values such that, see, x is to the left of 2, so x is less than 2, even 2 it will not have the value, and here to the right of 2, comma, x greater than 2. This will be the domain. So whenever there is a asymptote, we have to exclude those values. So x value 2 will be excluded from both sides. On this side less than 2, on this side greater than 2, but not equal to 2, okay? Then range is set of all y values. Again, how should be y? It will not have the value minus 1, except that any value upwards, any value downwards, okay? So if you have to write this as a set or as a interval, so y belongs to R such that y is greater than minus 1 and y is less than minus 1. It will be above this, it will be below this, but not on the line because they are the asymptotes. But look here, okay, this was above, so domain will be what? By now you understood x values. How are x values? It is going to the right, it is going to the left, anywhere, so x belongs to R. And range, y value, how should be y value? It is not going below the x-axis, so no negative y values, only positive, and it will not meet the x-axis also, okay? So y greater than 0, okay? That's it. Sorry, for example C here, for A, state the domain and the range. Domain of this question, C, how it will be? Greater than or equal to 0. So which means x greater than or equal to negative 6. This is the domain. Range will be, see, this everything of y is in the square root, and square root we know that is always positive, right? So you have to write the positive value, okay? Because x is not going to take that value. 1 minute, let me check this. Yeah, right? So the range of this will be y values such that y is greater than or equal to 0, because this answer cannot be negative for real function, right? Now next question, 1 by x square it is. So x cannot take 0 value, and for the range the total answer y cannot be below 0 or even 0, okay? So domain is x belongs to R such that x can take any value except 0. So x not equal to 0. And range also can take any value, but it cannot take the values of the asymptotes. So y greater than 0. Okay. Here we don't have asymptote, but then it should be greater than 0, because if it is 0, it will not be defined 1 upon 0. Okay. So I hope you understood this. Now the next part of this question. So I think I will leave it for you. I know that you can do them. So I'll leave it as a homework for you. Okay, you try these questions, or should I show you? Anyway, let me show you this one. Look here. Here x should not be 3. If x is 3, the denominator will be 0. So except 3, it can take any value. Therefore, domain will be all x values except 3. So x not equal to 3, right? And range will be, see, for the range, whatever value of x you put here except 3, the whole answer 1 upon whatever you have is never equal to 0, right? So it is the y values, y is never equal to 0, right? Like this. So you try C and D, right? Okay. Now next question, use technology to help sketch these functions. Okay. So on this calculator I am going to show you how to sketch this graph. So I'll type this. So what I will do, I'll write the steps for Casio CG50. Steps. What are the steps? Menu, then graph, then graph, and then type the equation y is equal to, y1 is equal to, you have to type this equation, x cubed minus 3x squared minus 9x plus 10, and I'll plot the graph. So draw, F6 I have to press. Now this graph should have window setting. I have to change the window setting. View window, it can be anything, so let me take negative 100, positive 100, something like that, negative 50, positive 50, and let me see the graph now. Yeah, see, I will do window zoom. See here, like this I have the graph. So I'll draw the graph, and from the graph you have to write domain and range. Now look here, you have to write the turning point of this graph also, because there will be maximum, there will be minimum, and there will be y-intercept and the x-intercepts will be there, right? So you have to write all those values. So let me first write what is maximum and what is minimum. Window setting, let me make x and y should be minimum, maximum, or minimum negative, maximum positive 50. Its coordinates are negative 1 and 15, and I will write minimum value also, G solve, and minimum coordinates here B, which will be 3 comma minus 17, and then I will find the roots, means where it intersects the x-axis. So it will be at negative 2.42, something is there, comma 0. Then next one is 0.917 I will write. Next one is 4.51 I will write. Then the y-intercept, let me check, G solve, y-intercept is at 10, 0 comma 10. Okay, that's it. I think this is sufficient. So this is the graph. What will be the domain and what will be the range? See, x values, it is taking any x values, and also y values, it is taking any y values. So x such that x belongs to R, all x real numbers. Range is all real numbers, y will take all real numbers, okay, because it is going up and up, going down and down, right? This graph again, now I will draw that graph. I'll delete this graph and type the next graph. To the power 4 plus 4x to the power 3 minus 16x plus 3. Yeah. Okay, I will draw it. Window setting, negative, what can I do? Take negative 50 and positive maybe 100 I'll put, and y I'll keep maybe 20, negative 20 and positive 50, no problem. Yeah, so now my graph is something like this. Origin. So it is something like this, it is, okay, something like this. Now wherever, no, not in this way, sorry, like this, it is not going on the negative side, okay. So I'll find y-intercept 0 and 3, so here is 3. I'll find x-intercept also, which are called the roots. First one is 0.189 and the second one is 1.59. I will write 3 significant figure. That's it, and this is the graph. So from the graph, what do you see? What is domain and what is range? Yeah. How are the x values? X, again, it is everywhere, so x belongs to R. But y is not everywhere. Let me find the minimum point on this graph. Yeah, minimum point is here, 1, negative 8. So it will not go below 8. So range will be, domain is all x values, but range will be y values greater than or equal to minus 8. Okay, because it will not go below that point, it will not go here, it will be above that point, okay, everywhere it will be above that point. Okay, then now reciprocal function, right? Reciprocal function means when you write the x terms are in the denominator, that is called a reciprocal function. For example, this is one example. I can write f of x is equal to 2 over x, okay, anything like this. F of x is equal to 5 over x, or f of x is equal to negative 10 over x. All these are reciprocal functions. This gives you the rectangular hyperbola, okay. But let me show you the graph of the given function. This one, graph of, it will always have the asymptote, x and y asymptotes will be there. I mean the horizontal and the vertical asymptote. Okay, so when you draw its graph, it will never be, x will never be 0, because here it is x, it will never be 0. So the y-axis will become as its asymptote. Look here, y-axis will be the asymptote. So I will draw a little away. And similarly, the whole value 1 upon non-zero value will never be 0. So y asymptote, I mean the horizontal asymptote, will be the x-axis. I will draw close to it. Yeah, like this. Okay, and then around it we are going to draw this graph. Oh, now look here, when x is positive, x greater than or equal to greater than 0 here, graph is in first and third quadrant. Okay, graph will be in the first and third quadrants, and in this case I will draw that graph here. See, for this graph, again x-axis and y-axis will be the asymptotes, but then the graph will be in a different place. I will put it very close to it. Yeah, I cannot put exactly. Okay, leave it like that. So here the graph will be in the second and the fourth quadrant because x is negative. F of x is equal to negative 10 over x. So when x is negative less than 0, graph in second and fourth quadrant. Okay. So like that you should remember, when the highest power of x is positive, the graph will be in the first and third quadrant. If the highest power of x is negative, then the graph will be in the second and the fourth quadrant, right? Okay then. Composite function. When two or more functions are combined together, they are called composite function. So look here, if you have three sets, like this, okay, then suppose A1, A2, A3, B1, B2, B3, F associates elements of set A to set B, and G associates elements of set B to set C, then it is called a composite function. Okay, so G dot F of x, we can write y is equal to G dot F of x. And how can we write it? So we can write it as G of F of x, right? Like this. We go from right to left. First we apply for F function, then we apply G function. So F will associate A1 to A2. So F of A1 will become A2, and G will associate A2 to A3. So finally A3 you get. Okay. So it means A1 is associated to A3. Okay, in the composite function. And composite function can be F dot G or G dot F. If it is G dot F of x, then first is F, then is G. Or if it is F dot G of x, then first we apply G, the rule of G, then we apply the rule of F. And like this, the composite function will be simplified. You can also write the composite function in this way, F of G of x. Okay, F dot G can be F of G of x, and G dot F can be G of F of x. Okay. Okay then. Now let us see some questions based on this. This is an easy part, so I am going fast. Suppose F of x is this, G of x is this. Find in simplest form F dot G of x, means the composite function F of G of x. So I will do A first part. F dot G of x will be F of G of x. Now what is G of x? G of x is this. Look here. G of x is this. So I will put this value 1 plus 3x. And then what is f? F is 2x minus x square. If x is inside f, then it becomes 2x minus x square. So this is inside x, so it will be 2 times that inside part minus inside part is square. Look here, x 2x, so 2 into this, x square, so minus bracket is square, right? We have to write in simplified form, so I will simplify this. 2 plus 6x minus 1 plus 6x plus 9x square, I am opening the bracket. 2 plus 6x minus 1 minus 6x minus 9x square. So here 6x and 6x will go, 2 minus 1 will be 1. So 1 minus 9x square, this is the simplified form of it. Then second part will be g dot f of x, right, which will be g of f of x. Now f of x is what? F of x is this 2x minus x square. So g of 2x minus x square, and g will apply on x as 1 plus 3 times whatever is inside the bracket. So 1 plus 3 times whatever inside the bracket. See here, x will become 1 plus 3x. So this will become 1 plus 3 times that. Okay, we will write in simplified form 6x minus 3x square. That's it. This is the simplified form. Find the values of x. B part says, for which f of g of x is equal to 3 times g of f of x. Is there space I want to write? Oh, there is no space. So what should I do? Let me make it smaller. This part I will make smaller. Okay. This part also I will make smaller. Sorry for that. Now here down I am going to write B part. B part says f of g of x. F of g of x is this. So 1 minus 9x square is equal to 3 times g dot f of x. G dot f of x is this. So 3 times 1 plus 6x minus 3x square. So 1 minus 9x square is 3 plus 18x minus 9x square. So both the sides have 9x square negative, so it will get cancelled. Okay. Then let me put a line here for the second part. Okay. Now what is remaining? 1 is equal to 3 plus 18x. 3 will come here, so minus 2 is equal to 18x. So x is minus 2 over 18. It means minus 1 over 9. This is the value of x. They wanted value of x, right? Okay. Now next section is about inverse function. Inverse function means finding the relation in the reverse order. So for example, if you have a function y is equal to 2x plus 1, then we have to find the reverse relation of it. How to find? I will show you later on. Now we can find inverse function if the function is 1 to 1, then only we can find inverse of it. This function is 1 to 1, means any linear function is 1 to 1. But if you have a function like y is equal to x square, then it is many to 1, and we cannot find inverse of this function. Okay, we can find for this, but we cannot find for that. So 1 to 1 function, which one? For each x there is only one y value, and for each y there is only one x value. Okay, so there should not be more than one x y values for same x value, or more than one x value for same y values. Equivalently, a function is 1 to 1 if f of a is equal to f of b only when a is equal to b. Okay, So as I said, linear functions are all one-to-one function, and many-to-one function are where you have y is equal to x square. Okay, there it will be. See, let me write many-to-one function here. When I write y is equal to x square, so here the graph is like this. In this, one value of y will be associated to two values of x, here and here. So here suppose minus 2 and 4, here 2 and 4. So same two different values of x are associated to one value of y. This becomes many-to-one function, right? Okay. Now one-to-one function satisfy both vertical line test and horizontal line test, isn't it? When you draw a straight line, see here, when you draw a straight line, any straight line, this is a vertical, this is a linear equation. It will pass the vertical line test and it will pass the horizontal line test, both the tests. It will meet only in one point, whether you draw a vertical line or the horizontal line, right? Then if a function is one-to-one, it will have an inverse. We can find its inverse and it is denoted by f inverse of x. Okay. Many-to-one function will be like this. I have already shown you this graph. It will not pass the horizontal line test. It will pass the vertical line test, no problem, but not the horizontal line test, because the horizontal line will meet it in more than one point. Of course, the horizontal line test is not there, but by horizontal line we realize whether it will be one-to-one or many-to-one. So this is many-to-one because it is meeting the curve in more than one points in two places. So therefore it is many-to-one, and if a function is many-to-one, it will not have an inverse. Does not exist. Inverse does not exist. Okay. Okay then. Now, what are the properties of the inverse function? A function f has an inverse function. F has an inverse function. This new function is denoted by f inverse, first thing. Then must satisfy the vertical line test, of course. Has a graph which is the reflection of f of x in the line y is equal to x. Okay. If you draw the graph of f and f inverse, so graph of f inverse will be exact reflection of f in the mirror line y is equal to x. Satisfy f dot f inverse of x is equal to x. Okay. Or f inverse of f of x is equal to x. Means if you apply both f dot f inverse or f inverse dot f, then it will remain x. The function y is equal to x is called the identity function because it is its own inverse. If you try to find the inverse of this, see, f of x is x. If you try to find the inverse, what we do to find the inverse? We replace x by y by x. So y is equal to x. It means f inverse of x is also x. So both will be the same function, f and f inverse. When both are same function, we call them identity function. Okay. In the same way, f of x is equal to 1 upon x is also an identity function. Its inverse will also be the same thing, f inverse of x 1 upon x. Okay. Self inverse function. So we already discussed when for the self inverse function, the graph is symmetrical about y is equal to x. See, I will show you the self inverse function of f of x is equal to 1 upon x. F inverse of x is also 1 upon x. Okay. So let me show you its graph. We have already seen the graph of y is equal to 1 upon x or f of x is equal to 1 upon x. So this is the mirror line. It is called a mirror line, y is equal to x. Now the graph of the function f is like this. Okay, now if I want to draw the graph of F inverse, it will remain the same. So it will be the same thing. So see, it is symmetric about the line y is equal to x. See, in this part and in this part, both the parts, it is symmetrical about the mirror line y is equal to x, right? Okay. Now this is the past paper question. We'll do few of the past paper questions. Okay. Now this question says f of x is equal to root of x minus 3 for x greater than or equal to 3. This is the domain of it. Without that it will not be defined. Find f inverse. Okay. So to find f inverse, what we will do? Let me write y is equal to square root of x minus 3. Will interchange x and y. So x is equal to square root of y minus 3. Then we'll square both sides. So x square is equal to y minus 3. Therefore y is equal to x square plus 3. And this will be the inverse function. F inverse of x is x square plus 3. Right? This is the inverse function. Okay. Now B part says, let g of x is x square plus 1. Find g dot f of 22. Let me do it here. That will be better in front of the question itself. B part. G of x is given x square plus 1. Now g dot f of 28 we have to find. What I will do? I will find f of 28 separately by putting it in this one. So square root of 28 minus 3. It is 25. Root of 25 will be 5. It will not be plus minus because it is already said x should be greater than or equal to 3. So it cannot be negative 5. Okay, so it is 5. So I will replace that here in place of f of 28. So it is 5. Now g of 5. So I will put g in this one and get the answer. So 5 square plus 1, 25 plus 1, 26. So this is the answer for this part. Now there is C part also. Write down the range of f inverse. C part I will do here. Range of f inverse is domain of f. Range becomes domain, domain becomes range. So domain of f will be the range of f inverse, but then instead of x we will write y. So x greater than or equal to 3. So therefore here we will write y greater than or equal to 3. It will become the range, right? Okay. Or we can also write it from 3 to infinity, right? And then this was the first part. Now second part says write down the range of g. So second part, range of g we have to find. Okay. Now g is like this. Now for range of g we have to know the domain of g, right? Domain, from the domain you can find range. What is the domain of g? Domain of g is all real numbers. But when you draw the graph of g, it is something like this. See, because g function is x square plus 1. So it will start from 1, 0, 1. Okay. So what will be the range? Y greater than or equal to 1. So range of g is all y values such that y greater than or equal to 1. Right? Okay then. Now next question. Second question says f of x is 5 upon x plus 1, x not equal to minus 1. For the graph of f, find x intercept, y intercept and equation of the vertical asymptote. Okay, we have to write x intercept, y intercept and the vertical asymptote. Now look here. For x-intercept, put f of x is equal to 0, right? When we put f of x is equal to 0 means 5 over x plus 1 is equal to 0. So no solution, we don't get solution. Therefore, there is no x-intercept, right? There will be no x-intercept, right? Okay, for y-intercept we should put x0. So second part it is, yeah, put x is equal to 0. So therefore f of 0 is 5 over 1, which is 5. Now this becomes the y-intercept, right? So therefore y-intercept is 0, 5, right? This is the y-intercept. Okay. Now the third part says the equation of the vertical asymptote. The third part will be find the equation of the vertical asymptote, right? We have to find the equation of the vertical asymptote. So for the vertical asymptote, what you have to do? See, when you draw the graph of this, y is equal to 5 upon x plus 1. So x should not be equal to minus 1. Okay. So vertical asymptote is x not equal to minus 1. X is equal to minus 1 because see, this function f of x is 5 upon x plus 1. So here x cannot be minus 1, therefore x is equal to minus 1 becomes the vertical asymptotes. Okay. Now the next part says, B part, let f of x, g of x is x minus 3, let me write that, g of x is x minus 3. Then the graph of f and g intersect at the point A and B. Find the coordinates of A and B. They both intersect, so we'll take them equal to each other. Okay, so f of x is equal to g of x. To find the point of intersection, f of x is 5 upon x plus 1, g of x is x minus 3. Bring this here and multiply. So they will give you 5 is equal to x plus 1 multiplied by x minus 3, right? So 5 is equal to x square when we multiply these together. X square minus 3x, then plus 1x, then minus 3. So x square minus 2x, from these two minus 2x, so x square minus 2x, minus 3 and 5, minus 5 will become minus 8 is equal to 0. When you factorize, it will give you x minus 4, x plus 2, right? So x is equal to 4, x is equal to minus 2. Put in any one of them, put it here, 4 minus 3, 1. So 4 comma 1, y coordinate. And minus 2 when you put, minus 2 minus 3 minus 5. So minus 2 and minus 5 are the 2 points A and B, we can call them, right? Okay. The next part says, C part says, find the equation of the straight line that passes through A and B. Okay. Okay, so C part I will write here. A is what? 4 comma 1. B is what? Minus 2 comma minus 5. So first we will find the gradient m is equal to y2 minus y1. Look here, this is the formula, x2 minus x1. y2 is minus 5 minus y1 is 1. x2 is minus 2 minus 4 is the x1. So minus 6 over minus 6, which will be 1. So gradient is 1. and point we can use 4 and 1. Therefore, equation of line through A and B is y minus 1. Look here, y coordinate I will use. M is 1, x minus x1 will be 4. So y is equal to x minus 4 plus 1. So y is equal to x minus 3. Okay. This is the equation of the line. Okay, next part is for write down D part. Write down the gradient of the line that is perpendicular to the line passing through A and B. Look here, gradient of AB is 1. Therefore, gradient of perpendicular line, its perpendicular line is minus 1. Because when two lines are perpendicular, the product of their gradient should be minus 1. So 1 multiplied by minus 1 will give you minus 1. Okay. Like this, the question is solved. There is another question now here. Okay. It says the function f is defined as f of x is equal to square root of 6 plus 2x upon 6 minus 2x between minus 3 and 3. Find the inverse function f stating its domain and range. Okay. So let me write y is equal to. Now we interchange. Interchanging x and y will give you x is equal to square root of. Okay. Now squaring both sides, x square is equal to 6 plus 2y upon 6 minus 2y. I'll take this there, open and multiply. So x square into 6 minus 2y is equal to x6 plus 2y. So 6x square minus 2xy is equal to 6 plus 2y. Bring this there and bring 6 there here. So 6x square minus 6 is equal to 2y plus 2xy. Dividing by 2 we will get 3x square minus 3 is equal to y plus xy. Y can be common from here because we want to make y the subject. 3x square minus 3. Now y is equal to, divide by this. So 3x square minus 3 upon 1 plus x. Okay. Or you can write x plus 1 also. 1 plus x or x plus 1. Right. Let me check 1 minute. Y and y. Oh, here it was x square, sorry. I should write x square here, x square here, x square here, x square here. So 1 plus x square, okay. Yeah, it will be in the denominator. 1 plus x square will be in the denominator. So this is the inverse function. Therefore, f inverse of x is 3x square minus 3 over 1 plus x square. This is the inverse function, right? F inverse of x. Okay. Now for domain and range, look here. Domain of f is what? Domain of f is given this one, so that will become the range. So range we will write first. Range of f inverse is domain of f. So which will be set of all y such that 3 minus 3 is less than or equal to y is less than 3, right? This will be the range. And domain of f inverse is range of f. Now what is range of f? see, for range of f, you have to find, is there space? Yeah, there is a space. So let me take this part there. I'll put this here, right? Now look here, let me write f, let me find the range of f so that I can find domain of f inverse. So f was 6 plus 2x divided by 6 minus 2x, right? Okay, and its domain was minus 3 less than or equal to x less than 3. Okay, so minus 3 is the value, so minimum value we will put f of minus 3, 6 plus 2 into minus 3 over 6 minus 2 into minus 3. So this answer I will find by calculator, square root of bracket, or directly I will simplify, 3 to the 6. So it will become 0, right? It will be exactly 0. So no need to find this because numerator is becoming 0. And f of 3 is not the value. So little less than 3 we will take, 2.99 we will take, just to check until what it is going to reach. So 6 plus 2 into 2.99 over 6 minus 2 into 2.99. So let me find what will be my answer, is square root of 6 plus 2 times 2.99 is the numerator divided by denominator 6 minus 2 into 2.99. This is my denominator. So final answer is 24.47. 24.47 less than 3. So it can be any value, isn't it? Now as you increase, look here, let me find numerator separately and denominator separately. So numerator is 6 plus 2 into 2.99, which is 11.98, and denominator is 6 minus 2 into 2.99, which will be 0.02. So as you take closer and closer value to 3, so as x tends to 3, the denominator will tend to 0. Okay, denominator will tend to 0 approximately. So it means the whole answer will tend to infinity. So therefore domain of f, range of f is infinite. Okay, range of the domain we have to find. So range is infinite, right, from 0 to infinity, because it cannot be negative, 0 to infinity. So therefore domain of f inverse is from 0 until infinity. Okay, I hope you understood this. Range we already wrote here. This is the range of f inverse. This is the domain of f inverse, right? Yeah. Okay, so with this we end this lesson, right? In next lesson we will take next part of the function, inverse function in detail we will study. Quadratic formula also we will check, then quadratic equation we will have, and then we can find its symmetry. Okay, how to find the axis of symmetry, right, and the vertex. Then reciprocal function also we will study in detail of this form also. Okay, so I hope you enjoyed my lesson, this lesson. If you like my lesson, please like, share and subscribe my channel on YouTube. And if you have any doubts, please contact me on my email ID or on my WhatsApp. The link of this PDF will be there in the description of the video. Okay then, bye.